All right. In this short video, I just want to answer this question: what is a definition? Now, oftentimes in real life, we think about a definition as sort of a description of what something is. But in mathematics, a definition is something very specific. A definition is a biconditional statement. A biconditional statement is a conditional statement that goes both ways. So each half of the conditional statement implies the other half. So let's look at an example. 1. An angle is a right angle. And then we have this little if thing, the IFF, which means, I'll put in parentheses here, if and only if it measures 90 degrees. And we can take this biconditional statement and break it down into two smaller conditional statements. So let's take a look at that. First, we have if an angle is a right angle, then it measures 90 degrees. So this means that if I show you an angle and I say, hey, this angle is a right angle, you can conclude it measures 90 degrees. So this part here implies or tells you that this part is true. The hypothesis of the statement implies that the conclusion is true. On the other hand, you could also say if an angle measures 90 degrees, then it is a right angle. So in this case, you can conclude, well, if an angle measures 90 degrees, so if I show you an angle and that angle measures 90 degrees, you can conclude that it is, in fact, a right angle. And we can take both of these parts of the statement here and we put them together. Hold on. If an angle is a right angle, then it measures 90 degrees. And it's converse, actually. If an angle measures 90 degrees, then it is a right angle. And we put these together into a single statement that says an angle is a right angle, and this IFF, which stands for if and only if it measures 90 degrees. And don't get too worried about breaking down what this if and only if means right here. It just means that I can split the statement, the biconditional statement, into two separate conditional statements. And this is what a definition is. It allows me to say, well, if, yeah, you can think of it as describing what a right angle is. A right angle is an angle that measures 90 degrees. But it also works in reverse. Well, if the angle measures 90 degrees, well, that type of angle is called a right angle. The definition goes both ways, and it allows you to link these two terms together. It links the term right angle with the measure of 90 degrees. All right, let's look at a couple more examples. Next we have collinear. 2, collinear. So our definition for collinear is, or collinear points anyway, points are collinear if and only if they lie on the same line. So on the one hand, we could say if points are collinear, then they lie on the same line. And on the other hand, we could say if, I'll get these two close together here, points lie on the same line, then they are collinear. All right, let's look at one more example of a definition. So in this case, by the way, just think about this. This allows you to conclude if I give you points that are on the same line, you can conclude that they're collinear. Or if I give you points and tell you that they're collinear, then you can conclude that they lie on the same line. The definition, again, like before, it links this term collinear with this fact about the points, links them together. All right, one more example. I'm going to look at the word opposite rays. So our definition of opposite rays is two rays are opposite rays if and only if they are collinear and have the same endpoint. By the way, notice we've got this and in here, which makes this technically a conjunction in this definition. There are two parts to this definition. So the rays, to be considered opposite rays, have to first be collinear and have the same endpoint. I do take a little bit of issue with this. I think that they should be unique rays, because I could have, well, we'll get into it. Anyways, so let's take a look here at how this breaks down. Oops, how'd that happen? There we go. So this breaks down here. We have if two rays are opposite rays, then they are collinear and share an endpoint, or have the same endpoint. On the other hand, if two rays have the same endpoint and are collinear, then they are opposite rays. So here goes both ways. If I tell you that two rays are opposite rays, then you can conclude that they are collinear and share an endpoint. On the other hand, if two rays have the same endpoint and are collinear, you can conclude that they are opposite rays. So it's a way of linking together, in many cases, a term like opposite rays or collinear or right angle, linking a term with something that you can observe in a diagram. Alrighty.